Look, I'm not going to lie to you. I'm not going to lie to you. Mathematicians, teachers, educators, principals, for the history of forever, have been trying to make dividing with decimals and long division with decimals easy. And I'm here to tell you, I've been teaching this a while. There ain't no way to make this easy. Like, no matter how you slice it, whether you're going to do old school or Common Core, dividing with decimals or long division period is a tricky, messy business. So if you stick with me to the end, I'll help you get to the end. But whether you decide to do it old school or Common Core method, whatever you want to do, it kind of depends on what kind of mathematician you are. So let's take a minute and talk about the different kinds of mathematicians that I've encountered in my classroom. So the first kind is creative. A creative mathematician likes to solve problems in ways that no one else thought of. They hate doing it the way the teacher showed them. Once they have an answer, though, they like to do it like 2 or 3 different times in 2 or 3 different ways and get the same answer, and then they feel confident that it's right. So if that's you, then I would say you're a creative mathematician. But I'm not talking to you today. The other kind of mathematician is an authentic mathematician. They need to understand every single step. They can't move on unless they understand each part. It usually takes them a long time to finish one problem because they authentically understand every step, right? This is a good thing. If you are an authentic mathematician, you're probably going to grow up to work in the mathematics field. And that's fine. Just in school, you're like, oh, why am I going so slow, right? Speed is not important. Meaning is, but not in this video. The last one I'm going to talk about is contextual mathematicians. Contextual mathematicians usually think that math is pretty hard because when they look at the problems alone and there's no context, they can't do it. But when someone talks to them about it, they usually get the answer. Or if they're given manipulatives to move with their own hands, put 300 in groups of 12, and then they move the things, they get it right every time. So if you're a contextual mathematician, this video is not for you. I will touch on authentic and contextual just a little bit, but this video is mostly for those efficient mathematicians. The people who like to use calculators. They want to know the fastest and the quickest way to solve the problem. If they get one answer, they're done and they move on. If you're an efficient mathematician, this video is going to turn you into a human calculator. You will be able to do long division with decimals without even looking at a machine, because you, my friend, will be the machine. So let's start off with our basic first problem, 36 divided by 20. Now, if we're talking about 36 divided by 20, I need you to write it a different way. You need to write it like this. And if you write it like this, then you read it differently. You read, how many groups of 20 fit in 36? And if you read it that way, it makes a lot more sense. But I'm going to warn you right now, if you don't line up your decimals, if you don't line up your digits, if everything is not perfectly, flawlessly straight, you're going to get it wrong. And that's why some people don't like this method, because if you lose your place, all the meaning goes out the window, you have to start again. So if you want to go get a piece of graph paper to make sure you line it up right, go ahead and do that. But let's just get started from here. First question, how many groups of 20 fit in 3? Show me 3 fingers. How many 20s do you have? None. So let's move on to 36. If I have a group of 36, how many groups of 20 fit in there? 1 group of 20 fits in 36. So 1 times 20 is 20. Subtract, bring down, right? So now the answer to my question is 1. 1 group of 20 fits in 36, but now there's 16 left over. And the old school way is we'd write remainder 16. But remainder 16 doesn't really mean much, right? So for the authentic mathematicians, we would say 16/20ths of a group. Right? So 1 group and 16/20ths of another group of 20 fit in 36. I hope I haven't lost you yet. Let's get a bigger number. So 369 divided by 12. And here we get the academic language. How many divisors fit into 3? 0. How many divisors fit into 36? 3. Multiply the outsides and write it at the bottom. So you could say 3 times 2 is 6. 1 times 3 is 3. Or you could say, I'm going to multiply the divisor and the quotient and write it under the dividend. 3 times 12 is 36. Subtract. Bring down. How many 12s fit in 9? That's my question here. How many 12s fit in 9? 0. 0 12s fit in 9. 0 times 12 is 9. Subtract, and there's nothing to bring down. So I would say remainder 9. Or the mature way, I would say 30 and 9/12. All right. But that's not what we're talking about today. I said we're dividing with decimals, and that, my friend, was a fraction. So before we get into decimals, you need to know where the invisible decimals are, right? And I know that's kind of weird, but if you think of this as $369, we all know where the decimal sign would go then if I put a dollar sign in a decimal. The decimal goes at the end of every number, right? And I guess we should start teaching that in kindergarten, that there's a decimal at the end of every number, but you know, kindergartners are struggling writing the number 3, so we kind of skip that. But at the end of every number, there's a decimal. And when we're dividing with decimals, we need to know where it is because we write it up there. Did you see that? And I can put as many number zeros here as I want, as many as I want, right? They're completely insignificant because $369, I can go all the way with those zeros. But now I have something to bring down. So I'm going to bring down that 0, and now I have 90. So now my question is, how many 12s fit in 90? I'm just going to tell you, it's 7. 7 times 12 is 84. Subtract, bring down. How many 12s fit in 60? 5. So 5 times 12 is exactly 60, and now I'm done because that's 0. So I don't need those extra zeros there. But you see how bringing down the 0 led me to the correct answer. So my answer now, not in fraction form, but in decimal forms, is 30.75. In other words, how many groups of 12 fit in 369? 30.75 groups. And I can put those zeros back if you want. But look, I'm telling you, if you don't line it up right, you're going to end up with the wrong answer. If I put 84 too much to the left, then I would have subtracted 9 from 4. It's gotta line up perfectly. So that is literally the most efficient, fastest way to do it. You will become a human calculator. Any digits I give you, any problem I give you, any place the decimal, you'll be able to solve it and get the answer the calculator gets. Okay? But not everyone's efficient. Some people are authentic, and that whole thing just confused the daylights out of them. This next part of the video is for the authentic people. So if you already get it, stop the video and go do your work, right? But if you need more, I'm going to give you more. If you need to understand every single step and you can't move on until you understand every part, this next part's for you. But I'm warning you, it's going to take a long time. Here is the 4 boxes. What is 3,648 divided by 12? Because we're going to leave decimals out of this for now. This is just going to be a long division. So what you do now with this 4-box method is you take 3,648 and you separate it into the boxes. 1 box per place value, okay? And then you put the divisor on the outside. And now you got to do some fancy thinking. So I'm going to start off with this first box here. How many 12s fit in 3,000? 1. Okay, maybe more than 1. 10. 10 times 12 is 120. Okay, so I could fit more than that. How about 100? 100 12s would be 1,200. So I know at least 100 12s can fit into 3,000. What about 1,000? Oh, no, that's too big. That would be 12,000. So let's stick with 100. So 100 12s would give me 1,200. 200 12s would give me 2,400. Okay, so now I know 200 12s make 2,400. But I still have some left over there, you see? I have about 600 left over. I can still fit more 12s in that first box. So let me try 10. 10 times 12, okay, I can fit another 10, I bet. What about 20? Let me add another group of 12. Well, no, I still need more than that. Let me add another, no, still need more than that. Let me just skip to 50. If I had 50 groups of 12, that would be, is 600. Oh, that's perfectly the 600 I had. Okay, so now I know that in 3,000, that there are 250 12s in 3,000. Okay, now I can move on to the next box. Oh, look, it's 600 too. So now I already know then that 50 12s fit in 600. Okay, so now I'm left with 40. Okay, so now I'm going to start with 3. So let's see. 3 times 12 is 36. So that means I got 4 left over. I can't fit another group of 12 in that 4. So I'm just going to move the 4 over to the other side here because that's the leftover part, the remainder part. And so 8 plus 4 is 12. Oh, look at that. 8 plus 4 is 12, which means I can fit one more 12 there. So now I add all those up. And that means 50 plus 100 plus 100 plus 50 plus 3 plus 1 is 304. Okay, so now if you are an authentic mathematician, that made sense to you because every single group, every single number wasn't accounted for. And the truth is, I don't really care if you're an efficient mathematician or an authentic mathematician. All I care about is that you are struggling with the math and you're working through it and you're trying to do what makes sense for your brain and you're coming up with the right answer. Now, I agree, the answer to the problem is not math. I could have just handed you a calculator, right? I could have said, here's a calculator, calculate this all out. But I want to teach you how to think, right? So either I'm going to turn you into a human calculator or I'm going to turn you into an authentic mathematician. Which one you want is up to you. All right, so that is the end of our lesson today, dividing with decimals, long division with decimals, and sometimes you just got to get rid of that decimal, multiply by 100 or whatever. So Common Core or old school, whichever one wins out is up to you. Now, get to work.